Welcome to qnawire.
Okay. We need to consider this following reaction. We have a bromine here, and it's reacting with OH minus. All right. Now we're told here, basically in the little toolbox, that when we have OH minus and a bromine, we're going to get some kind of elimination product. We're going to do an elimination and get an alkene out. So what we need to consider is where are the hydrogens that could be eliminated, or the protons that can be deprotonated while the bromine leaves. So we need to look at the neighboring carbons. If we're starting with our bromine here, then we need to look at the neighboring carbon here and here. So there's a hydrogen here, and there's a hydrogen here. Okay. Now, assuming we perform this reaction using the hydrogen on the left, we're going to create a double bond between these two carbons when the bromine leaves. And assuming we remove the hydrogen on the right, we'd create a double bond between these two carbons when the hydrogen leaves. So we got to ask ourselves, which of these would be a more stable product, right? So I'll draw the two, and then we can determine, right? So we're going to get a double bond. Let's not do red. It's an accident. Okay, so we know we're going to get a double bond, methyl, methyl, and then an ethyl. That would be this version. And the other version would be a double bond here, methyl, and then a isopropyl. Okay, so which of these is more stable? Well, when it comes to alkenes, the stability is determined by how substituted it is. That means how many carbon groups are coming off the alkene. In the first case, we have 1, 2, 3 carbon groups and 1 hydrogen. In the other case, we've got 2 hydrogens and 2 carbon groups, 1 and 2. So the more substituted alkene is more stable when we don't have to consider sterics. OH is a small, very agile base, so sterics aren't important. It's just going to follow Zeitze's rule and give us the most stable product.